Imagine a factory floor in 1968. Hundreds of relays. Thousands of wires. And every single time a car model changed, engineers had to physically rewire the entire system. From scratch. How long do you think that took? Weeks. Sometimes months. And it cost General Motors millions of dollars every single year, just to keep up with change. So someone asked a simple, dangerous question. What if you didn't have to rewire anything at all? That question, asked in a small engineering meeting in 1968, would permanently change how the entire world manufactures everything. From the car you drive, to the water coming out of your tap, to the phone in your hand. This is the story of the programmable logic controller. The invisible brain of modern industry. And almost nobody knows it exists. Before we get to the solution, we need to understand just how bad the problem was. For the first half of the 20th century, industrial machines were controlled by relay logic. Relays are simple electromagnetic switches. You send electricity through a coil, it creates a magnetic field, and a physical switch flips. Sounds simple enough, right? Now imagine needing 500 of them. All wired together. All dependent on each other. If one relay failed, and they failed constantly, a technician had to trace through hundreds of connections by hand to find the problem. It was slow. It was fragile. And it was expensive. But here is what made it truly unsustainable. Every time the production line changed, new car model, new product, new process, the entire relay panel had to be redesigned. New wires. New relays. New diagrams. Can you imagine rebuilding your entire control system from scratch every time you updated your product? That was the reality of 1960s manufacturing. And General Motors had enough. In 1968, General Motors issued a challenge to engineering firms across the United States. They needed a new kind of control system. One that could be reprogrammed without rewiring. One that was solid state, meaning no moving parts. One that a factory technician could actually understand and maintain. Who would answer that call? A young engineer named Dick Morley, and his team at a company called Bedford Associates, came up with something they called the Modular Digital Controller. They filed the concept in 1968. And within a year, they had spun off a new company specifically to build it. That company was called Modicon. And their first device was the Modicon 084, named because it was the 84th project the team had worked on. Not a glamorous name. But what it did was extraordinary. Instead of physical relays, the Modicon 084 used a microprocessor. Instead of fixed wiring, it used software, a program you could write, change, and reload without touching a single wire. Think about that for a moment. In 1969, the same year humans walked on the moon, a factory floor in Detroit could be reprogrammed with software. The relay era was over. It just didn't know it yet. But here is a problem that nobody talks about. You have built a brilliant new device. It works. It is faster, cheaper, and more flexible than anything before it. So why would the people who spent 20 years mastering relay panels suddenly trust a computer they don't understand? They wouldn't. And they didn't. This is where the designers made a decision that was, frankly, genius. Instead of forcing factory technicians to learn a new programming language, they made the PLC speak the language technicians already knew. They called it ladder logic. Ladder logic is a programming language that looks exactly like a relay diagram. The same symbols. The same structure. The same visual logic that electricians have been reading for decades. Except now, those symbols controlled software, not physical wires. It was a bridge between two worlds. And it worked brilliantly. Technicians who had never touched a computer in their lives could program a PLC within days. Because to them, it didn't look like programming at all. It looked like the job they already knew. Have you ever wondered why ladder logic still exists today, 50 years later, when almost every other programming language from that era has disappeared? That is why. It was designed for humans, not computers. And that single design decision has outlasted everything around it. Through the 1970s and 1980s, PLCs spread from automotive plants into every corner of industry. Water treatment facilities, power plants, oil refineries, food processing lines, pharmaceutical factories. Anywhere a machine needed to make decisions, a PLC was there. Companies like Allen Bradley, Siemens, and Mitsubishi entered the market. Each with their own version. Each competing to be the brain of the industrial world. But here is something that should surprise you. As PLCs became the backbone of global manufacturing, the people buying groceries, driving cars, and drinking clean water had absolutely no idea this technology existed. PLCs became the most important technology most people have never heard of. By the 1990s, PLCs were controlling systems responsible for a significant portion of global industrial output. And yet, ask anyone on the street what a PLC is. You will get blank stares. Why do you think that is? Because PLCs don't fail visibly. They just work, quietly, reliably, invisibly, behind walls and inside panels, running the same cycle thousands of times per second, year after year. The best technology is often the technology you never notice. Now, a question that engineers argue about constantly. In the age of cloud computing and artificial intelligence, is the PLC becoming obsolete? Some say yes. Modern systems combine PLC reliability with PC-level computing power. Cloud platforms can now monitor entire factory systems remotely. So why haven't PLCs disappeared? Because of something called determinism. A PLC, when given a command, responds in a guaranteed amount of time. Milliseconds. Every single time. No background updates. No network lag. No unexpected processes stealing processor time. In a factory where a 1-second delay can destroy a product, or injure a worker, that guarantee is everything. Cloud systems are fast. But they are not deterministic. And in industrial control, fast enough is not good enough. You need guaranteed. What is actually happening is a convergence. PLCs are gaining connectivity, talking to cloud systems, feeding data to AI platforms. But at the core, at the moment of control, there is still a PLC making the decision. Dick Morley solved a problem in 1968 so well, that 50 years later, the world is still building on top of his answer. Not many engineers can say that. From a wiring problem in a General Motors plant, to a question asked by a young engineer, to a device that now quietly runs the infrastructure of modern civilization. The next time you turn on a light, fill a glass of water, or drive to work, somewhere in that chain, a PLC made a decision. In less time than it takes to blink. That is the profession archive. Where the technologies that run the world finally get the story they deserve. If this gave you something to think about, subscribe. Because next time, we are going inside another profession that changed everything. And you probably don't know its name either.